Hey, what's up, guys? Welcome back to my channel. So today we are going to look how to use SolidWorks design library to create meshing gears. So let's get it started. So first of all, let's go to design library and Toolbox, and let's do add in now. And we are going to use ANSI inch. So before you start, make sure your units here is set it up as English units. So inch here, then click on ANSI inch, then scroll down to power transmission, then gears. So we have all different types of gears here. And the most commonly used one is called spur gear, which is this one here. And also it has others. So let's create two spur gears and mesh them together. So it's two gears. So the smaller one, we call it as pinion. And the bigger one, we call it as gear. So in order to be able to mesh together, those two gears have to have the same diameter pitch. Okay, let's create the first gear. So click on spur gear once, then right click on it, then click on create part. Then we have a spur gear created. Then let's specify the parameters. So the first one is diameter pitch. So like we said, the two gears, they have to have the same diameter pitch in order to be able to mesh together. So let's make the diameter pitch of this pair to be 12. Then the number of teeth for the smaller one, the pinion, let's make it to be 38 teeth. And the pressure angle, let's make it to be 20. And the face width, let's make it to be 1.5, enter. And the hub style here, it could be none, could be one side or on both sides. So let's just make it to be none. And the nominal shaft diameter is talking about here. So let's make it to be 3/4 of an inch. And let's add a keyway as a rectangular one here, a keyway here. And this is our first spur gear, which is also pinion. Then say OK. Then it's over here. Then let's save the work. And make sure you save all of them in the same folder. Otherwise, you may not be able to open it. So this is our first one. Then save. All right, then let's make another one. And still go to design library, then spur gear, then right click on it, then create part. Okay, as we mentioned, the diameter pitch, they have to be the same. So let's keep it as 12. Then the number of teeth, right now, let's make it to be 46. And the pressure angle, face width, they have to be the same as well. And the shaft diameter, let's still make it to be 3/4. And all others, let's keep it the same. Then say OK for the configuration. Then let's save our second gear. So the second one here, which is bigger, 46. Then let's save the work. Make sure they are in the same folder. So spur gear, 46 teeth, 12 diameter pitch, 20 pressure angle, 1.5 face width. Then save. Okay, now we are going to assemble them together. So let's create a new assembly file. Okay. All right, we are going to bring in the part So let's bring in the smaller one first. Then click on Browse. Bring the smaller one in, then open. It's over here. Then let's bring in the other one as well. Insert components, and the bigger one. Put it here. Then if we choose the front view, it will give us like this. So we really want the front view to be in this way. So we are going to do some mates. So before we do that, we are going to do simulation of the movement of the two gears. So it's not going to be fixed. So we will need to delete this fixed condition. So first of all, let's click on the first one, then right click on it, then click on float. So the gear is free to move. And also we want the gears to be on the front plane. So let's add some mates. So click on mate. Then make sure it's on the standard one. Then we are going to make the back surface on the front plane. So let's click on the back surface of the smaller one. Then expand this arrow here. Then select front plane. And they are coincident. See if it's the right direction. Yeah, looks right. Then say OK. And a similar thing, let's select the back surface of the bigger gear and select the front plane. And looks right. Then say OK. So now let's give a front view. OK, they look good to us. Then say OK for mate. Okay, next one, we are going to add a mechanical mate so the two gears can rotate together. So before we do that, we will need to be able to see the pitch diameter of each gear. So the way we can see them is we unhide the pitch diameter. So expand this arrow here, then go to tooth cut. Then click on the sketch and click on show here. So as you can see, the pitch diameter is showing up. So for gears, we could have major diameter and a minor diameter inside. So pitch diameter is a diameter that could represent the gear. So it's called a pitch diameter. Besides that, we could also have basic diameter. Then similar thing, let's do it for the second gear, tooth cut, then make it to be visible. So now we see there's two pitch diameter. So now let's grab the bigger gear and move it close to the smaller one and make the teeth to mesh. Then at the same time, have the two pitch diameter to be tangent. So something like this. And it looks like the teeth, they can mesh together. Okay, then let's save the work first and make sure they are still in the same folder. Rebuild. Yeah, still in the same folder. Then save. Then before we move forward, let's make sure the units here is still in English units. So now let's add the mechanical mate. So click on mate here, then click on mechanical. Then we are going to select this two pitch diameter. So delete this one here, then select the two pitch diameters, then select the gear. So they actually automatically calculated the ratios here, which is pitch diameter. So pitch diameter is the number of teeth divided by diameter pitch. So the first gear, the number of teeth is 38. The diameter pitch is 12. So this is the number. And for the second one, the number of teeth is 46. And the diameter pitch is 12. So the pitch diameter is 3.83 inch. Then looks right. Then let's say OK. Then close mate. All right, the next one, we are going to add motions. So let's click on motion study here. Then let's save the work first. Then first of all, let's define the simulation time. And for our project, I think 8 seconds would be enough. So drag to 8 seconds. Then let's do some setting. Click on motion study properties. Then frame per second, I think 30 is probably a good number. Then go to basic motion here. So still make it to be about 30 frames per second. Enter the high accuracy and high resolution. Then say OK. Then since we are going to have rotary motion, so we probably need to add a motor there. So let's click on this motor so we can add a rotary motion. So click on motor here. And it says pick a direction. So let's click on the circle of the second gear. And the speed, let's make it to be about 6 RPM, which is for revolution per minute. Then say OK. OK, then let's do the calculation. So click on calculate. Looks good for me. OK, looks right to me. So before we move forward, let's hide all those unnecessary sketches. So let's go back here. And the tooth cut, let's hide it back. And a similar thing for the first one. Tooth cut, hide. So the sketches, they are gone. Then let's play it one more time. Looks good. So the smaller one is always rotating faster than the bigger one. And you could also save the animation. Then click on Save Animation here. Then we are going to save it as MP4. Then say Save. Then the smaller gear always rotates faster than the bigger one. All right, then let's save the work again. All right, this is all we have about how to use SolidWorks design library, the toolbox, to create meshing gears. Thanks for watching. We'll see you next time. Bye.